For hallway floor illumination with recessed wall fixtures, several options are available. Firstly, the Lightolier Lightus by Mini 810 is a recessed wall-mounted fixture designed for installation at approximately 12 inches above the finished floor level. It incorporates a parabolic reflector which helps in directing the light downwards. This model is available in both incandescent and fluorescent versions. Secondly, the Juno Track Lume Low Profile is a recessed track fixture, also intended for installation at approximately 12 inches above the finished floor level. A key feature is its adjustable lamp head, which allows for precise control over the beam angle. It is compatible with a range of low-voltage MR16 and G-Uton lamps. Thirdly, the Nora Lighting M Series 102 is a recessed wall-mounted fixture designed for installation at approximately 14 inches above the finished floor level. It features a wide beam angle, suitable for illuminating a larger area, and is available in both LED and fluorescent versions. Fourthly, the Amerlux Tresor Path is a recessed wall-mounted fixture intended for installation at approximately 12 inches above the finished floor level. It is specifically designed for stair or pathway lighting, providing a narrow beam angle for precise downward illumination. Fifthly, the Lutron CL2 Recessed is a recessed wall-mounted fixture designed for installation at approximately 12 inches above the finished floor level. It features a swivel lamp head, allowing for adjustable light direction, and is available in both incandescent and LED versions. The Stairmaster 880LL, a stair lighting option recommended by the supply house, is a recessed step light with an adjustable beam angle, and is available in incandescent and LED versions, and typically installed directly into the stair tread. When selecting a fixture, consider several factors. The fixture's size needs to be appropriate for the hallway dimensions and the desired aesthetic. The light distribution pattern is critical for achieving the desired floor illumination effect. Consider whether a wide or narrow beam angle is more suitable. It's crucial to ensure compatibility with the existing electrical system, including voltage requirements and wiring configurations. In general electrical circuits for lighting, several principles apply. Firstly, voltage is the electrical potential difference that drives current through a circuit, measured in volts. Common voltages in residential and commercial settings are 120 volts and 277 volts, respectively. Secondly, amperage is the measure of electrical current flow, measured in amps. The amperage rating of a circuit breaker or fuse determines the maximum current that the circuit can safely handle. Thirdly, resistance is the opposition to current flow, measured in ohms. The resistance of a conductor or component affects the amount of current that flows through it for a given voltage. Ohm's law, expressed as voltage equals current times resistance, describes the relationship between these three quantities. Electrical power, measured in watts, is the rate at which electrical energy is consumed or dissipated. It is calculated as power equals voltage times current. When selecting conductors for electrical circuits, it is essential to choose the appropriate wire gauge based on the ampacity requirements. Ampacity refers to the current carrying capacity of a conductor. The National Electrical Code, or NEC, provides tables such as NEC Table 310.15b16 that specify the allowable ampacities for different wire gauges and insulation types. These tables take into account factors such as conductor temperature rating, ambient temperature, and the number of current-carrying conductors in a raceway or cable. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices interrupt the flow of current when it exceeds a predetermined level. Circuit breakers are resettable, while fuses are one-time use devices that must be replaced after they blow. Grounding and bonding are essential for electrical safety. Grounding provides a low impedance path for fault current to return to the source, helping to prevent electrical shock. Bonding ensures that all metallic parts of an electrical system are electrically connected, minimizing the potential for voltage differences. Ground fault circuit interrupters, or GFCIs, are devices that detect ground faults, which are unintentional electrical paths between a live conductor and ground. GFCIs quickly interrupt the circuit when a ground fault is detected, reducing the risk of electrical shock. Arc fault circuit interrupters, or SIs, are devices that detect arc faults, which are dangerous electrical arcs that can cause fires. SIs quickly interrupt the circuit when an arc fault is detected, preventing fires. Electrical boxes are enclosures that protect electrical connections and provide a safe mounting location for devices such as switches, receptacles, and lighting fixtures. Electrical boxes are available in various sizes and materials, including metal and plastic. Conduits are raceways that protect electrical wiring from damage and provide a pathway for running wires. Conduits are available in various materials, including metal and plastic, and in different types, such as rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Wiring methods refer to the techniques and materials used to install electrical wiring. Common wiring methods include non-metallic sheet cable, armored cable, and conduit wiring. Each wiring method has its own advantages and disadvantages, and the appropriate method depends on the specific application and local electrical codes. Electrical codes and standards, such as the NEC, provide comprehensive guidelines for the safe installation and operation of electrical systems. These codes and standards are developed by organizations such as the National Fire Protection Association, or NFPA, and are regularly updated to reflect advancements in technology and best practices. Proper electrical safety practices are essential to prevent electrical shocks, fires, and other hazards. These practices include wearing appropriate personal protective equipment, such as gloves and safety glasses, using insulated tools, and energizing circuits before working on them. Regular inspections and maintenance of electrical systems are important to identify and correct potential problems before they become serious hazards. These inspections should be performed by qualified electrical professionals. When working with electricity, it is important to follow lockout/tagout procedures to ensure that circuits are de-energized and cannot be accidentally energized while work is being performed. Lockout/tagout involves placing locks and tags on circuit breakers or other disconnecting means to prevent them from being turned on. Surge protection devices, or SPDs, protect electrical equipment from voltage surges caused by lightning strikes, power outages, or other events. SPD divert excess voltage away from sensitive equipment, preventing damage. Power quality refers to the characteristics of electrical power that affect the performance of electrical equipment. Poor power quality can cause equipment malfunctions, data loss, and other problems. Power quality problems can be caused by factors such as voltage sags, voltage swells, harmonics, and transients. Energy efficiency is the practice of using less energy to perform the same task. Energy-efficient lighting, appliances, and other equipment can save money on energy bills and reduce environmental impact. Renewable energy sources, such as solar, wind, and hydropower, can provide clean and sustainable electricity. These sources can help reduce reliance on fossil fuels and lower carbon emissions. Smart home technology allows homeowners to control and monitor their electrical systems remotely, using smartphones, tablets, or other devices. Smart home features can include lighting control, energy monitoring, and security systems. Electric vehicle charging stations are becoming increasingly common as electric vehicles gain popularity. These stations provide a convenient way to charge electric vehicles at home, at work, or in public places. Electrical safety audits are comprehensive assessments of electrical systems to identify potential hazards and ensure compliance with electrical codes and standards. These audits should be performed by qualified electrical professionals. Electrical training and education are essential for electricians, electrical engineers, and other professionals who work with electricity. These programs provide the knowledge and skills necessary to safely and effectively install, maintain, and repair electrical systems. The National Electrical Code (NEC) is a comprehensive set of standards for the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years by the National Fire Protection Association (NFPA). Article 90.1 of the NEC outlines the purpose and scope of the code. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Chapter 2 of the NEC covers wiring and protection. It includes articles on branch circuits, feeders, and overcurrent protection. Chapter 3 of the NEC covers wiring methods and materials. It includes articles on various types of cables, conduits, and raceways. Chapter 4 of the NEC covers equipment for general use. It includes articles on receptacles, switches, and lighting fixtures. Chapter 5 of the NEC covers special occupancies. It includes articles on hazardous locations, healthcare facilities, and agricultural buildings. Chapter 6 of the NEC covers special equipment. It includes articles on electric signs, electric welders, and electric vehicles. Chapter 7 of the NEC covers special conditions. It includes articles on emergency systems, standby power systems, and fire alarm systems. Chapter 8 of the NEC covers communications systems. It includes articles on telephone systems, data networks, and cable television systems. Chapter 9 of the NEC contains tables and examples. It provides information on conductor ampacity, conduit fill, and other calculations. The NEC is a complex and comprehensive document. It is essential for electricians and other electrical professionals to have a thorough understanding of the code in order to ensure the safe installation and operation of electrical systems. The NEC is not a design manual. It provides minimum safety requirements. It is the responsibility of the designer to ensure that the electrical system is adequate for the intended use. The NEC is enforced by local jurisdictions. It is important to check with the local authorities to determine which edition of the NEC is in effect and any local amendments. The NEC is constantly evolving. It is important to stay up to date on the latest changes to the code. The NEC is a valuable resource for anyone involved in the electrical industry. It provides the information necessary to ensure the safe installation and operation of electrical systems. Always consult with a qualified electrical professional when working with electricity. Electricity can be dangerous. It is important to take precautions to avoid electrical shock and other hazards. Always de-energize circuits before working on them. Use insulated tools. Wear appropriate personal protective equipment. Follow all applicable electrical codes and standards. In summary, selecting the appropriate recessed wall fixture for hallway floor illumination requires careful consideration of factors such as fixture size, light distribution, electrical system compatibility, and compliance with electrical codes and standards. Consulting with a qualified electrical professional is recommended to ensure safe and effective installation.